Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation focused on DTC P2135, which denotes TP sensor AB incorrect voltage correlation in the Honda CRV model years 2017 to 2022. This issue can arise from a malfunction in the throttle position sensor, which plays a crucial role in relaying the throttle angle to the powertrain control module, PCM. The throttle position sensor has two channels, A and B, that must communicate the same voltage levels to ensure accurate engine performance. If there's a discrepancy in the voltage reported by these sensors, this DTC code is triggered. It's important to take this error seriously, as it can affect vehicle responsiveness and power delivery. We will delve deeper into the components involved, symptoms, possible causes, and a step-by-step troubleshooting guide to effectively resolve this error. DTC P2135 indicates an incorrect voltage correlation between TP sensor A and TP sensor B, both critical components situated in the throttle body. The throttle position sensor, TPS, monitors the position of the throttle valve and relays this information to the PCM. It consists of two separate sensors to provide redundancy and improve reliability. However, if these sensors deviate in their voltage readings, the PCM detects this issue and generates the error code. The throttle body, where the TPS is physically mounted, is located between the air intake manifold and the engine, making it a vital component for regulating airflow into the engine. Issues with the TPS can lead not only to poor engine performance, but can potentially cause safety concerns due to hesitation in throttle response. Understanding the possible causes of DTC P2135 is essential for targeted troubleshooting. A faulty throttle position sensor is the most common cause. Wear and tear or internal failure can lead to inaccurate voltage readings. Moreover, poor electrical connections can disrupt the communication between the TPS and the PCM, contributing to this error code. Additionally, wiring issues like frayed or shorted wires can also result in incorrect signals being sent from the TPS to the PCM. Finally, an internal malfunction of the PCM itself could lead to improper readings, making it crucial to check both the sensor and the module thoroughly. Each of these issues can independently trigger DTC P2135, necessitating a detailed inspection. Symptoms associated with DTC P2135 typically manifest as a warning light and operational anomalies. The check engine light, CEL, will illuminate, indicating an underlying fault within the vehicle's control system. Drivers may also notice poor throttle response, where the vehicle may not accelerate as intended upon pressing the gas pedal. This can lead to reduced engine performance, impacting drivability and overall experience. In more severe cases, power loss during acceleration can occur, posing a safety concern, especially in high-speed conditions. Identifying these symptoms early is crucial for preventing further mechanical issues or safety hazards. The first step in troubleshooting DTC P2135 begins with verifying the problem. Start by turning the vehicle to the on mode, which allows the onboard diagnostic system to function properly. Once in this mode, the next critical action is to clear the DTC using the Honda Diagnostic System, HDS. This process resets the system and erases prior error codes, giving you a fresh slate to work from. After clearing the DTC, select the ETCS test from the function test menu within the HDS. This procedure allows for stress testing the electronic throttle control system. Finally, check for any confirmed or pending DTCs that may be indicated on the HDS display. If DTC P2135 appears, it confirms that the failure has been duplicated and further action is warranted. In Step 2, the focus shifts to determining the possible failure area, particularly the PCM or other related components. Begin by turning the vehicle to the off mode, ensuring that no power is flowing through the system. Next, utilize the HDS to jump the SCS, service check signal line, allowing for electronic diagnostics. It's important to wait for more than 1 minute after this action. Following this, disconnect the PCM connector B, identified as 51P. With the connector removed, check for continuity between test points 1 and 2, specifically PCM connector B, number 46 and number 47. If continuity is detected, it indicates a viable connection, suggesting the PCM may not be the issue. If continuity is absent, further investigation is necessary, potentially including consulting service data or substituting a known good PCM. In the third troubleshooting step, the focus narrows to check for a shorted wire between the THL1 line and the THL2 line. Begin by disconnecting the throttle body 6P connector, which houses the connections for both throttle position sensors. With this connector removed, check for continuity between PCM connector B, number 46, and number 47. If continuity exists, this indicates a short circuit in the wiring between these two terminals that needs to be addressed, requiring repair of the THL1 wire to the THL2 wire. Conversely, if no continuity is detected, it confirms that the wiring is intact, leading to the necessity of replacing the throttle body, as it may be defective. Each of these steps is vital for isolating the issue and restoring proper functionality. After completing the necessary repairs for DTC P2135, it's crucial to verify that the vehicle operates correctly before concluding the process. Start by reconnecting all connectors that were previously disconnected during the troubleshooting steps, ensuring secure connections to avoid future errors. Following this, clear the DTCs once more using the HDS to reset the system. After clearing, conduct a test drive to assess the vehicle's performance under real-world conditions, focusing on the throttle response and overall operational stability. Finally, confirm that the error has been resolved by checking that no new DTCs appear, ensuring that the corrective actions taken have effectively remedied the situation. Preventive maintenance is key to ensuring long-term reliability and performance in vehicles like the Honda CRV. Implementing regular system diagnostics can help catch issues before they escalate into serious problems. During routine inspections, pay particular attention to wiring and connectors associated with the throttle position sensors, as corrosion or fraying can lead to future fault codes. If any sensors show signs of wear or abnormal performance, replacing them proactively can extend the lifespan of the throttle control system. Additionally, keeping the vehicle's software updated ensures that it can adapt to any new fixes or enhancements designed to improve system accuracy and reliability. In conclusion, DTC P2135 serves as a critical warning of an issue with the throttle position sensors in the Honda CRV models from 2017 to 2022. Following the outlined troubleshooting steps methodically is essential for accurately diagnosing and addressing the root cause of the error. Once repairs are made, it's imperative to verify their effectiveness fully to ensure the vehicle operates optimally and safely. Finally, implementing a preventive maintenance schedule, which includes regular diagnostics and inspections, will mitigate the likelihood of encountering similar issues in the future. Proactive care not only enhances vehicle reliability, but also improves driver safety and overall satisfaction. Please like and subscribe to the channel. See you next time.